In this lecture, I will talk about Euler's formula, a tool for expressing another kind of natural change, cyclical change. We've seen how E can be used to express natural growth, natural decay. Now what else? Whether you are growing bigger or smaller, it's still of the same type. The change is only about size. But what if the change is from one thing into another? That's how Euler's formula comes into play. E is a shortcut to express continuous change. So whatever on top of E can be used as the rate of change inside. Then we can expand it using the binomial theorem. The only part that needs change is the rate of R. Now it's imaginary number. All others stay the same. For continuous growth, n becomes infinity. These fractions become 1. Now we have a series of imaginary polynomials. Then, using the definition that I squared equals to minus 1, we get a real part and an imaginary part. Coincidentally, one is cosine and the other is sine. If you set x to pi, you get Euler's identity. But what does it mean? Our struggles result from the lack of understanding about imaginary numbers. First of all, what does I even mean? When we multiply 1 by 1 plus 1, we get 1 plus 1, which is 2. But if we multiply 1 times 1 plus I, times 1 remains 1, but times I gives us I. And we would just leave it like that. Why we don't add them up and say it's 2? That's because they are fundamentally different things. So this I means a completely different ingredient as opposed to 1. In geometry, they are placed 90 degrees to one another, meaning that they are independent. They won't interact with one another. Then, what does times I mean? It changes one thing into another. So this multiplication by I changes from one ingredient into the other. And if we multiply by 1 plus I again, the times real number keep things unchanged. The times I will change red to yellow. But what about this I times I? Times I will change it to the other dimension, so it should be a real number. But why minus 1? It means this element is having negating effects on the red one. So don't think of these numbers as quantity of certain things, but think of them as reactions to one another. So these elements will offset the impacts of the red one. They are in the same dimension. They can react to one another. That's why you can add them up. Multiply by I again, it becomes the other ingredient, offsetting the yellow one. Change again, you're back to the original. If you keep multiplying I 5, 6, 7 times, the cycle repeats. So we have ingredients along 2 dimensions. One dimension won't affect the other, but along each dimension, we have 2 elements opposing against one another. These opposing elements are Y. E with real number on top will run away with an increasing X, but it will not run away with imaginary numbers on top. If we color them according to their elements, now we try different X. X being 1, we have half a unit of green element, roughly 1 unit of red. The green one has negating effects, so the result is 0.54 units of red. Similarly, the I elements also react to one another, becoming 0.84 units. As X get bigger, both increases, but now the green dominates, resulting in 0.4 unit of green. Both I elements increase too. Now yellow gets a bit stronger. With increasing X, all the individual elements increase, but not proportionally. Sometimes green dominates, sometimes red dominates, sometimes yellow, sometimes purple. As we keep increasing X, the dominant role keeps switching in a harmonic way, resulting into oscillation between two elements. What this means is we would observe a harmonic transition between the two offsetting elements. Same thing can be said about the other pair. These two fundamental ingredients go through their own cycles. One starts full, getting smaller, the other starts empty, getting bigger. You can almost view this as two ingredients constantly changing into one another. The cycles can repeat on and on. But what do we mean when we add them? Once you combine the ingredients, you're creating a mixture. You're creating a holistic experience with different flavors. All these different flavors give us a spectrum of perception of this and that. For example, force along these or that direction. Regardless of the object here, in math, we can think of those states forming a circle. Each point on the circle represents a possible state. Then moving along the circle means naturally changing from one state to the other, cyclically. So the circle here is the circle of all the states. All these states have unit length from the origin, meaning that although they have different flavors, they have the same energies. Now, to refer to a specific state, you use its location on the circle, which is the angle here. So X here means the angle on the circle, which is the face of the cycle you're at. So if we have e to the power of I pi, it means the phase at half cycle. It should be a -1, meaning the 1 unit of the negating element. E to the power of I 2 pi, that's a full cycle, so it's 1. In the future, I will explore the use of Euler's formula in quantum physics and signal processing.